Welcome children. Hope you are safe and in home. You are healthy and safe at home. During this corona pandemic, be safe children. Don't come out to play. Yes, you are the leader wherever you are. You will follow whatever the government is giving instructions. Please follow them. You be hygiene. Wash your hands for 20 seconds so that all the microbes in your hand is washed away. You should be healthy and safe. And during this time also, we should make the most of it. Let us learn some interesting and important topics. Yes? Yes, children. You are sitting in front of the TV. What are the things that you are seeing in your room? You are watching movie, you are watching TV. You can see tables, chairs around you, clock, calendar, all these things you can see. When you go out, you see trees, animals, rivers, mountains, etc. Yes, we also use many things like soaps, detergents, pastes, etc. And we smell a lot of things. The perfume of the agarbatti, the perfume of the scents, many scents, and also sometimes the bad odor from the drainage. Yes, and then we cannot see air, but we can feel. Sometimes when cool breeze comes, we can feel the air. We feel hot, we switch on the fan. We need air. So what are all these things, children? Yes, these are all the matter around us. Yes, we perceive all these things, we are perceiving through our senses. These matter we are perceiving through our senses. All these things are matter around us. Everything around us is matter. Yes, and these even living and non-living things are matter. So, matter is having all living and non-living things that are perceived through our senses. I am matter, you are also matter. Yes, children. So, everything which can be perceived around us by our senses is matter. Now, I want to tell you a story, children. Okay? You like to listening stories, right? Now you must have listened this story many times. Once there was a crow called Kalu. It was very thirsty on a very hot summer day. So it was going in search of water. And finally, after a lot of time, it could see a jug of water. Yes, it tried to drink its water from the pitcher, but it could not reach. So it kept on trying. Then finally it saw some stones around. So it put stones one by one into the jug. And finally the stones all came down and water level rose. So it drank all the water. And it was very, very happy and flew away. So children, you see that when the crow, what did it do? It tried. It did not give up. So one of your commandment, right? Never give up. Now after listening to this, I want to ask you some questions. I want to ask you 3 questions. Okay? See, in the picture, with which material is the jug made? What is the special property? The second one, what could have happened if the crow used small plastic balls instead of stones? The third question is, if the crow used rock salt, could it be able to quench its thirst? Yes, yes children. Now, you can easily tell in that picture that it was a glass and the crow could see the water in the jug. Yes. So, Yes, children. We will see that gas has what special property? Let us see. Glass is, children, glass and some materials like transparent materials will allow light to pass through them so that you can see the things which are on the other side. Now, this is a plastic sheet, children. It is transparent. When I am putting it in front of my face, are you able to see my face? Yes, you can see my face because this is a transparent sheet and it is allowing light to pass through it. All the light which is coming from this side is passing through this. So, you are able to see what is on the other side. Now, children, can you see my face if I put this object? No. Why can't you see? Because this is a cardboard. It is made up of cardboard and it is not allowing light to pass through it. So, that is why you are unable to see my face. Such substances which do not allow light to pass through them are called as opaque substances. They do not allow light to pass. In our house, we see walls. Can you see the persons on the other room? No. So, walls are opaque. All those substances which do not allow light to pass through them are called as opaque substances. Now, children, there is one more type of substance. See, children, observe this. Can you see through this? You may notice only some faces there behind, but you cannot see it clearly. Such substances will allow light only partially through them. That is why you cannot see the whole thing clearly. Such substances are called as translucent substances. So, children, based on the property of passage of light through the substances, substances are divided into three: transparent substances, translucent substances and opaque substances. Transparent substances allows all the light to pass through them. Translucent substances will allow only some light to pass through them, and opaque will not allow light to pass through them. Now, coming to the second question, children. What is the second question? If the crow used plastic balls instead of stones, would it be able to drink the water? No, you all know that some objects float and some objects sink in water. It all depends upon the density. If the density of the object is less than water, then it will float on water. And if the density is more than water, it will sink. We will learn about density in the following. In this lesson after some time. Now, imagine, children, that why some objects are floating. When an object is placed in water, it displaces some water. If the weight of the displaced water is more than the object, then the object will float. And if the weight of the displaced water is less than the weight of the object, then the object will sink. Yes, this is about the second question. Now, we go to the third question. Children, if it would have put salt, would it have been soluble? Yes. If it used rock salt, it would not have been able to quench the thirst. The crow would be unsuccessful. Why do you think so? Yes, the rock salt would have dissolved completely in water and it will mix well and the level of water will not rise. So, children, some lime juices which will, some are, you say, such a type as to be soluble. The salt is completely soluble in water. That is, it mixes and dissolves well in water. The other example is, if you put lime juice in water, it is also soluble. If you put sugar, it is also soluble. So, some substances are soluble and some substances are insoluble. For example, if you take a glass of water and put sand in it, however you mix for so much time, it will not dissolve. In the same way, if you put some oil on water, it is also not soluble. So, these materials, some are soluble and some are insoluble in water. Now, we have seen about, now we have to see more scientifically explained matter. These are the properties which are we see regularly. Now, we want to explain, I want to explain the matter in a more scientific way. Children, now look at this. If you have a book in front of you, please take the book and put your book on your left hand. You feel some heaviness? Yes. If you put a bigger book or another book, you still feel the heaviness. What is this? You can easily lift an empty bucket, right? But if the bucket is full of water, will you easily lift it? No, because water in it has some mass, right? Even air has mass. We can see an experiment where two balloons are tied to a scale and they are balanced equally. See, children, there is an orange balloon and a blue balloon in the slide. If you prick the blue balloon, what is happening? The scale is tilting towards the orange balloon. So, this shows that air has mass. So, what is mass? Mass is the quantity of matter present in an object. So, all the stuff which is present in the objects is mass, and we measure mass in kgs, yes, in grams or kgs. Usually, we mistake both weight and mass to be the same thing, but mass is more a fundamental quantity. In measurements, you have seen that mass is a fundamental quantity. Weight, children, is the force with which that earth, we are on earth now. So, the gravitational pull on the object, the force of gravity is acting on an object. This is called weight. Weight is given by multiplying mass into acceleration due to gravity. It is a force. It changes from place to place. If a person is having 60 kgs on earth, if he goes to moon, then do you know what his weight is? It is only 1/6. He will be only 10 kgs. That is, weight is changing from place to place. But is his mass changing? No, his mass is same. It's same on earth and it is same on moon or on space. Wherever he will go, mass is a fundamental quantity. It is the amount of the quantity of matter which is there in the object. Now, we find one more thing, children, that matter occupies space, right? Now, let us do an experiment to show that water occupies space. Children, see this. I have taken a glass full of water, right? And I am putting a stone in it. What is happening, children? Yes, the water is overflowing. The water is overflowing. So, this stone has occupied some mass. Now, children, this is a balloon. The balloon has some air has occupied mass. See, children, here it was up to the brim. Now, when I put this stone, the water fell down. So, what can you see? That this stone has occupied some mass and displaced the water which has fallen out. So, from this we will understand that stone is also occupying space and water also needs space. Then air, children. See this balloon. It is filled with air. So, air is occupying all the space here. So, all the objects will occupy space. Children, on your birthday, you get gifts, right? You have to put the gifts in the cupboard. So, some space is required for them. If we go to the market, we buy so many groceries. We go with an empty bag and the bag is filled with groceries. So, they also occupy space. So, matter occupies space. Now, the space occupied by this matter is called volume. So, volume is the amount of space that is occupied by matter. Its units are liters, cubic centimeters, etc. So, children, we have seen and we can define matter as something which has mass, which occupies space and is perceived by our senses. So, we say that matter has mass and occupies space. Matter has mass and occupies space. Examples we have all book, pen, train, everything around is showing this. So, coming to the definition of matter, let us zoom into the microscopic view of what a matter is made up of. Yes, children. Now, matter is made up of very, very tiny particles which are called as atoms. All matter, everything you think of is made up of very, very small tiny particles called as atoms. Okay? And the history of atoms dates back to 450 BC, where a Greek philosopher, Democritus, he wondered what would happen if you cut a piece of matter, for example like an apple, into smaller and smaller and smaller pieces. He said a point would be reached where it would be impossible to cut that small piece, and he called this small tiny particle as atomos, which means uncuttable or indivisible. Yes, this is where we get the name for atom from. But we know, children, that atom is divisible now. It has protons, neutrons and electrons. We will read about it in another class. We will discuss about it in another class, the following class. Yes. Now, we will go and see what are these atoms. Yes, children. And how tiny they are. Yes. These atoms are so tiny that they are measured in angstrom units. And 1 angstrom is 1 into 10 to the power of minus 10 meters. Such a small number. We are unable to see them because they are very, very small. We need a microscope, a powerful microscope to view these atoms. How many atoms do you think will be there in a tiny speck of dust? A tiny speck of dust we see. We can't even imagine that there are about 3 million atoms in a small tiny speck of dust. Such a large number, 3 trillion atoms, right? So, these atoms are very, very small and you need a very powerful microscope to see these atoms. Children, if you go, take a piece of gold and zoom into it through a powerful microscope, I can see tiny, tiny atoms in it. Yes? If I divide the gold into 2 pieces, then also I can see the tiny particles of gold. Yes? And these tiny particles of gold will have the same physical and chemical properties as the gold. And if I divide again and again, I may get 1 particle. So, this also belongs to a tiny particle of gold. So, a substance which is made up of only one kind of atoms is called an element. The substance which is made up of only one kind of element is called as an element. Yes, children, when I saw into this gold, I found that all the properties of this atom are same. All the atoms are of the same kind. But if we take iron atoms, they are also all one kind, but the atoms of iron are completely different from the atoms of gold. So, you can call this as an iron element and this as a gold element. So, a substance which is made up of only one kind of atoms is called an element, right? And till now we have discovered 118 elements, and they are given specific symbol and we see them in the periodic table, right? So, they are made up of, all the elements are made up of small tiny atoms of the same kind. Now, children, some atoms can't exist on their own, right? They combine to form molecules. For example, if you take an oxygen atom, O is its symbol. It can't exist on its own, but it combines with another oxygen atom to form O2, which is called as a molecule. So, atoms combine to form molecules, and they can exist separately and they have the properties of the substance. They show all the properties of the substance. So, we have seen that elements contain only one kind of atom, and if you want to divide it into simpler substances, we cannot do it either by physical or chemical means, and they can exist as atoms or molecules. Even an individual atom of oxygen you can call it as an element, or if you have a cluster of oxygen molecules also, then also you can call it as an element, right? So, molecules combine to form, atoms combine to form molecules. Now, suppose this oxygen molecule is having the same kind of atoms, but if different kinds of atoms combine, then you get a compound. For example, children, water. Water has 2 atoms of hydrogen and 1 atom of oxygen. It will combine in the ratio of 2:1. Yes, when these two combine, it forms a compound water, and this water is completely having different characteristics from the elements which it is formed. So, children, this hydrogen is a very combustible gas, oxygen is a supporter of combustion, and both are gases. But water which is formed by these two elements do not have these properties. It is in fact a liquid and used to put out fire. So, the properties of the compounds are completely different from the properties of the elements from which it is formed. Okay? So, compounds contain atoms of 2 or more different elements combined in a fixed ratio. They can be broken down into their elements by chemical means, but not by physical means. So, water can be divided into hydrogen and oxygen only by chemical means. Yes. Now, after coming to this, we come back to matter and see that before that I want you to do a small exercise. Now, can you identify which is an element and which is a compound? Yes, children. The first one is water. You already know it is a compound. The second one, yes, it is copper. It is having only one type of atom. So, it is an element. What about the third thing? Can you see it? C6H12O6. It is glucose. It is having 3 types of atoms. So, it is a compound. The fourth one, NaCl. NaCl is a salt we eat daily. It has 2 types of atoms, sodium and chlorine. So, it is a compound. The fifth one, children, oxygen. It is having only one type of atom. So, it is an element. And the sixth one, sodium. It is having only one type of element, that is Na, and it is also an element. Yes, children. We come back to our properties of, and we will use the term atoms or molecules for our further discussion. I will call them as particles for a convenience. These may be atoms or molecules or even ions. Ions are charged particles, right? It is so, instead of calling all atoms or molecules, in our further discussion, I will say that they are just particles. Now, matter is composed of these atoms or molecules. I want to tell you about the 3 important points to remember while discussing about the matter. So, why these 3 important, they are important, I will tell you. The first one is, when matter is composed of some particles like atoms or molecules, they have vacant spaces between them. Yes, they have vacant spaces between them, and there is a force of attraction between them, and there are motions. Now, children, look at this. Imagine that these white balls are atoms, right? I want to show you that there are vacant spaces between them. Now, imagine that these are the molecules or atoms of any substance. If I put some substance in this, let us see what happens. So, you can see that there are empty spaces in between the atoms. We can say that all matter is having empty spaces in them. Now, the second point, there is force of attraction between them. Okay, children? Now, this is a steel scale. I try to break it, doesn't break. Why? There is a force of attraction between the particles of the scale. Yes. Now, I take a chalk piece. I can easily break it, right? So, this has less force of attraction between its particles. So, and they are always in motion, children. Always the particles in any matter are moving, and the movement, it is due to the energy they possess. Right? So, all the particles are moving. So, remember these 3 points. There are vacant places between them, there is a force of attraction between them, and they are in motion. Now, children, based on these 3 properties, we can see why they become solids, liquids or gases. Okay, children. Now, we will see in general, even a small child can know by seeing whether a substance is solid, liquid or gas, right? Now, we will see what some common properties of solids. Now, see here, children, you can see these 4 objects which I have placed, right? Let us do some maths here, okay? What is this, children? What is the shape of this? This is a cuboid, right? And this is a cube, What about this? This is a sphere. And what about this? It is some irregular shape. It is an irregular shape. So, we can, by seeing them, we can tell the shapes of these objects, right? Now, what is the volume of this? We can find it out mathematically. The volume of the cuboid is length into breadth into height, right? So, we can find the volume of this by using a formula. In the same way, the volume of the cube is a cube. If the side is a, the volume can be derived by a cube. Now, what is the volume of this sphere? It is 4 by 3 pi r cube, right? Now, how can I find the volume of this irregular object? It is easy, children. I can use the Archimedes principle. See, I am putting this object in water. Yes, the liquid or water displaced by this is the volume of that irregular object. So, in this way we can find the volume is definite. It is definite for all the solids. So, we can say that the shape is definite and even the volume is definite for solids. So, solids have a definite shape and a definite volume. Now, what about liquids? Do you think they have a shape? Okay, children. Now, look here. I have taken 4 containers, right? Now, look at this. I have taken 100 ml of water. Can you see, children? This is 100 ml, right? Now, while I am pouring water from one container to another, please observe the shape, right? Now, I am pouring this water into this container. What has happened? The water has taken the shape of this glass. It has changed the shape. Now, if I put into another container, the shape of this water also has been changed. Now, I am putting into another smaller container. Yes, children. Now, you observe the volume. See, you observe the volume. It is again 100 ml. So, I have started with 100 ml and I have poured it into different containers. All through it was 100 ml and finally also it is 100 ml. That means the volume has not changed. The volume is same. This shows, children, that liquids do not have a definite volume, definite shape. Liquids do not have a definite shape. They take the shape of the container, but the volume is definite. Yes. Now, coming to gases. Do gases have definite shape and definite volume? Let us see. Yes, gases do not have definite shape. They also take the shape like liquids. They take the shape of the container, right? Now, this is a bottle of oxygen, right? Now, it is taking the shape of this. What would happen if I take this and shift it to a larger container? Now, gases are greedy, children. They will occupy the whole space of the larger container. And the volume of the gas will be now the volume of the larger container. Yes. Now, if I shift the gas molecules into a smaller tiny bottle, then I can compress with pressure and make it fit into a small container. So, the volume of that gas will now be the volume of the small container. So, children, here you observe that gases have no definite shape or no definite volume. So, children, now we know about shape and volume and we can easily tell it. Solids have definite shape and definite volume. Liquids do not have definite shape. They take the shape of the container, but they have definite volume. See, we buy many things, right? Like milk, kerosene, petrol. This according to this volume. And gases, children? Gases do not have shape nor volume. So, we have seen this in this thing. Now, we can observe the other properties of solids and all these properties, why some are solids, why some are liquids and why some are gases, we will see in the three properties which we have discussed, the important points, how they are vacant spaces and force of attraction and all. Now, coming to solids, see children, in the diagram, you can see in solids, all the particles are arranged in a systematic manner very close to each other. Yes, all the blue dots, you think they are particles. In liquids, they are not so close to each other and they are moving little farther away from each other. And in gases, you see that they are far apart. The molecules are far apart when compared to liquids or solids. So, the arrangement of particles we show that in solids it is close and a regular pattern, not so close and in random arrangement in liquids, and far apart and in random arrangement also in gases. Now, coming to the movement of particles, right? When these are closely packed, children, they vibrate on its own in the mean position. Yes, they vibrate in their places, they move a little, but in liquids, they can move a little more. They are having little more movement because they have little space between them. And in gases, the movement is very less. Now, coming to the attractive forces, because why they are so near? Because solids are having minimum distance between them. So, the force of attraction between the particles is very, very strong. Children, the solids are having minimum intermolecular distance. You can call it as the distance between the particles as intermolecular distance. Now, solids have minimum intermolecular distance. Why? Because the force of attraction between the particles is very, very strong. And what about liquids, children? Liquids, you know that they are little less closely packed. So, the force of attraction between these liquids is a little less when compared to solids. And for gases, they have maximum space and least force of attraction between the two particles. That is, the force of attraction is less for gases. Right? Now, what about the movement? Because all the particles are moving, we say that they possess some kinetic energy. So, in solids, we see that they have least kinetic energy and the particles are just able to move around its own position. In liquids, they are in continuous random motion and they can easily flow when compared to solids. And in gases, they go in any direction and they are free to move. Now, I can show the movement with my fingers, children. Just look at my fingers. Look at my fingers, children. Yes. Now, you think that these fingers are the particles. They are tightly, closely packed in solids and just they are moving around their mean position in this way. Now, for liquids, they are a little far apart and they are able to move a little more. So, they have little more kinetic energy when compared to solids. And in gases, they are able to move very fast. That is, they have a lot of kinetic energy. So, based on all these properties, that is, solids have minimum space, maximum attraction between the particles and least kinetic energy. we will see other properties, children. Now, see this, a solid. Now, we go to compression. Compression means to compress it and make it occupy lesser volume. Am I able to compress this solid? No, even if I use force, I can't compress it. Do you know the reason, children? Yes, I think you know. Because in solids, the particles are already very near. There is no place for them to come more near. That is why these solids are rigid and they are incompressible. Yes. And what do you think about liquids, children? Do you think I can compress liquids? Now here I have bottle filled half with water. I can compress it a little. But do you think I am compressing the liquid? No, children. Actually, I am compressing the air in this. Right? A fully filled bottle, if you try to compress it, I can't compress it so much. So, even liquids are not so compressible, right? Now, what about solids, gases? I'm sorry, what about gases? Yes, gases are highly compressible, children. They are very compressible. Now, pushing air, we see that volume occupied was very less and we made the gas to occupy a small container. That means we have compressed the gas. And for the use of this compression is, we see that nowadays in LPG, that is a cooking gas, gases are compressed under high pressure and they are made portable. Yes, even CNG, compressed natural gas, which is used as fuel in a vehicle, is an example of compressibility of gases. Yes, children. Now, let us go to the next thing. Our liquids, solids, liquids. We have this liquids. Now, you look at this. What I am able to do, children. See, I am able to pour this liquids and the water is flowing. The substances which flow, children, are called as fluids, right? Do liquids, gases also are fluids? Let us check. The substances which flow, why do these flow? The liquids, why do they flow? Because there is less attractive forces between the molecules, they are able to flow. Now, can you see that gases also are fluids or they are not? Now, I will open this bottle, children. Yes, you can see the gas flowing out. No, you cannot see it because air is colorless. If the gas would have been bromine, if it would have been colored, then you can see that gases also flow. They can move from one place to another place. And collectively, these liquids and gases are called as fluids. Yes, we know that liquids and gases can flow and they are collectively called as fluids. Now, children, what is about after compressibility and fluidity, we come to the density. Density we have seen before that matter has mass and volume. The comparison between this mass and volume, that is, if you divide mass by volume, we get density which is given by rho and its units are grams per centimeter cube. So, you know definitely that solids, because they are very close, they are denser than liquids and liquids are denser than gases. Now, sitting in front of this TV and watching, and your mom is preparing some nice food for you, children. Yes, you might get the nice smell of aroma from the kitchen. How did it come to you? Your mother is in the kitchen cooking food for you and here you can smell it. Yes, children, the aroma or gas vapors have traveled from the kitchen to you, and this is called diffusion. So, what is diffusion? The movement of particles from an area of higher concentration to area of lower concentration is called as diffusion. The example for this, children, can you see the movement of particles in this agarbatti? Yes, you can see that they are diffusing, right? We have, so what is diffusion? Is the gas, oxygen gas is diffused in water, and the aquatic animals are able to see. Now, if you see a tea bag, if you put in hot water, you also can see the diffusion. Even the gases, the exchange of gases taking place in our lungs, that is oxygen and carbon dioxide, it is also an example of diffusion. So, diffusion is the movement of particles from a region of higher concentration to a region of lower concentration. Now, so we have seen all these examples of diffusion. We know that solids do not diffuse in solids because there is no movement in this, and liquids diffuse in liquids and also in gases, and the diffusibility of gases is the most, children. Diffusibility of gases is most, because you know the answer. The particles of the gas move very fast and randomly, so they diffuse very fast. Now, the speed with which they diffuse is called the rate of diffusion. Now, let us see what is the rate of diffusion of gases and what does it depend on. Now, look at the screen, children. Then experiment to show the diffusion in gases. Now, I have taken a long glass tube and which is graduated, that is, the distances are marked, and I take two cotton plugs, one dipped in ammonia and the other in hydrochloric acid, and I insert between the two ends at the same time and plug and close it. Now, you observe when the cotton which is dipped in ammonia gives out ammonia gas, which is NH3, and the hydrogen chloride gas is given out by the other cotton, and they travel. When they meet, children, what will happen? A reaction takes place when they meet, and white ammonium chloride is formed. See, this is the reaction between ammonia and hydrogen chloride. So, when ammonia reacts with hydrogen chloride, white fumes of ammonium chloride are formed. So, coming back to our experiment, we see that where do we see the white fumes of ammonium chloride form? Right here. Yes? So, what do you think? Ammonia gas has travelled so much distance, while hydrogen chloride gas has travelled only this much distance. So, we can say that here the two gases have met and ammonium chloride. So, this is about diffusion. Now, children, we have another property of liquids, solids, liquids and gases. Solids, liquids and gases expand on heating and contract and on cooling. Children, we see railway tracks. There is given small gaps between the railway tracks. Why? Because during summer, where it is very hot, the tracks due to the heat may expand, and if there is no gap, it may go out of shape. So, to avoid this, small gaps are given in the tracks. Now, we do a small experiment to show that solids expands on heating, right? Now, watch this video which says that Solids
will do a
expand.
small experiment to show that solids expand on heating. Now I have taken this small apparatus where I have taken a small ring made of steel, and I have taken an object which is a stone. I have placed it. The diameter of the stone is a little larger or the same size as that of the ring. That is why the ring doesn't pass through the stone. Now let us heat the ring and see whether it passes. Now I have taken this ring and I am heating it. As the rings get heated, its size enlarges. It becomes bigger in diameter. Now the diameter of this ring is larger. Let us see what happens when I place this ring on the stone. See, it has easily passed through the ring. In the same way, if I cool this, again this ring contracts. Let us cool it. On cooling, this ring again contracts and comes to its original size. So on placing the ring again here on this stone, it doesn't pass. So we can say that solids expand on heating and contract on cooling.
Okay children, now what about liquids? Liquids, example for expansion of liquids is the thermometer we use, right? When we are sick and have fever, we see the temperature with a thermometer. In the thermometer, it can be made of two types of materials, mercury or alcohol. So this mercury expands when it's heated. So liquids expand on heating. This principle is used in the construction of thermometers. What about gases, children? Gases also expand on heating, and this is used for the hot air balloon. When the hot air balloon, the heat is given, we see that it expands and rises above. Now we do a watch a small video to show that gases also expand on heating.
That gases expand on heating and contract on cooling. Now I have taken a small empty bottle which is having air in it, and I have fixed a balloon with the help of a tape. Inside there is air. I have taken hot water and I am going to heat the air inside this bottle by putting this bottle in this hot water. Observe what happens to the air inside. The air inside is expanding and it occupies more space. And you can see the balloon, the air is filling the balloon and balloon has become larger. This is due to the expansion of air in the bottle. Now, what happens if the air inside this is cooled? Now, I take cool water and place this bottle in cool water. Now, look at what is happening to the air in the balloon. It is getting contracted and the balloon is deflated. This experiment shows that gases expand on heating and contract on cooling.
Yes, children. So today we have seen the properties of all the solids, liquids and gases. Yes. Now for the questions, children. What water and ice are made up of same type of molecules, that is H2O. ice is a solid whereas water is a liquid. We know that solids are denser than liquids. Then why does ice float on water? Find out the answer. Now, you can see this. Imagine, see children, the second question which I am going to ask you is, see this. You see that sugar I am pouring from one container to another slowly. I can see that sugar is also flowing, right? And it is taking the shape of the container which it is put. Yes? Now, can you say what that sugar is a solid or a liquid? And if yes or no, substantiate your answer. If it is a liquid, do you think that sugar is a liquid or a solid? This is your second question. And one more question I want to say, children, that there are other states of matter other than solids, liquids and gases. Please go through the net and find the answer. Thank you very much.